Good day everyone. I am Ethel Magpatak, a BSBE marketing student, and today I want to share with you the linear programming simplex maximization method containing greater than symbols. But before that, I want to answer with you the following question. What is linear programming? What is simplex method of maximization? What are the rules in solving the problem? And what is the difference between Krapikov method and simplex method? Linear programming simplex maximization method containing greater than symbols. A linear programming is a mathematical technique for maximizing or minimizing a linear function for several variables, such as outputs or cost. The simplex method begins at the corner point where all the mean variables, the variables that have symbols such as x1, x2, x3, etc. are 0. It then moves from a corner point to the adjacent corner point, always increasing the value of the objective's function. Number 1. Set up the problem. That is, write the objective function and the inequality constraint. Number 2. Convert the inequalities into equation. This is done by adding one slack variable for each inequality. Number 3. Construct the initial simplex tableau and write the objective function in the bottom row. Number 4. Calculate the quotient. The smallest quotient identifies a row. Number 5. Perform pivoting to make all other entry in this column 0. Number 6. When there are no more negative entries into the bottom row, we are finished. And number 7. Read off your answer. First, we need to write what to maximize your inequality constraint. So to maximize f is equal to x plus zy, subject to this is your inequality constraint. X plus y is less than or equal to 13. Then, 2x minus 3y is greater than equal 6. And then x is greater than the equal to 0. And y is greater than or equal to 0. Next, we need to add a slacks variable because we have our inequality and add the slack variable to the equality constraint. Next, we're going to make an initial tableau. So this is our tree tableau. After adding a slacks using initial first tableau, distribute the variables and find the pivot variables or pivot column. So this is our tableau, our pivot column. After identifying our column, let us now choose our pivot entry by forming a quotient and choosing the entry giving a smallest possible quotient. In the second tableau, by dividing our pivot entry to other entry, after repeating the process to become up the third tableau, that having a no negative variables. So as you can see, that x is equal to 9 and y is equal to 4, so our maximum value of f is equal to x plus z is equal to 17. Example number 2. A factory of table makes two types of it, type A and type B. The factory makes a profit of 30 pounds of table for type A and 50 pounds of table for type B. Each table requires 5 meters squared to produce. Type A is a handmade table and type B is a standard option that 30 man-hours are required to produce each of the table for type A. Whereas, a machine is going mass of the work with type B, so only 10 man-hours are spent inspecting and finishing each table. Given the 150 meters squared of wood and 1,500 of man-hours are available each week, how many of each type of table should be made per week to maximize the profit? So based on our problem, we're going to maximize and write our inequality constraint. So we need to maximize P is equal to 30A plus 50B, subject to A plus B, that is an representation, is less than or equal to 30, and 39 plus B is less than equal to 100. So to equal to 0 and B is greater than equal to 0. Our second step is to add slack variables to this is how it's going to turn out after adding slack variables. Our third step, we need to make our initial tableau. For our first constraint, our pivot variable is negative 20, and we take the constant in the last column and divide them by their corresponding value for the pivot column for the first constant, then we divide by the pivot, which result to our second table. We're just going to repeat the process until we have no negative on the bottom. And it also result to our third tableau. As we can see, we have no negative value or variables at the bottom part. After that, we conclude that 600 is the final answer.
Example number 3. The firm produces 3 products, A, B, and C, each of them having different departments: the fabrication, finishing, and packaging. The product A requires 4, 5, and 3 hours. B requires 4, 3, and 3 hours. And C requires 2, 3, and 4 hours. Every day, 6 hours are available in the fabrication department, 70 hours in finishing, and 110 hours in packaging department. If the unit contribution of Unit A is $10, $20 for B, and $10 for C, then determine the number of units of each product so that the total contribution of the cost maximized, and also determine if the capacity would remain unutilized.
So as we remember the step, we can now solve a simplex method by identifying the problem and find what to maximize and to write your inequality constraint. And we should add a slack variables, then turn out this one you need to add slack variables for each inequality. And now, we're going to make an initial tableau. Then we should find the biggest negative value because that will be our pivot column. Our pivot value is negative 20 until we come up to no negative value. So that would be the end of our discussion. I hope you learned about what I have discussed earlier. Thank you. Bye.